And we're back. As you recall from last time, we talked about the relationships between pressure, volume, temperature, keeping one of them constant, and what happens to the other two. A reminder for pressure-volume relationships: as we increase pressure, volume is going to decrease. So if we put pressure on something, it's going to get smaller. And vice versa. If we decrease pressure on something, if we take the pressure off, it's going to expand and the volume is going to increase at constant moles and constant temperature. Okay, so let's look at a few problems and some of the problems from one of your worksheets. Okay, here's our first example. A sample of helium has a volume of 5 liters at 1 atmosphere of pressure. What is the volume if the pressure is increased to 3 atmospheres? Okay, so right off the bat, let's figure out what we're talking about. So we're talking about volume and we're talking about pressure. Okay, so what does the problem tell us? Let's kind of anticipate what our answer should look like. Sample of helium has a volume of 5 liters at 1 atmosphere of pressure. What is the volume? So they want the final volume if the pressure is increased. So let's draw our little diagram there. Pressure is increased. What's going to happen to our volume? So if pressure is increased, our volume is going to get smaller. Okay, now let's write down our initial and final conditions. So we're just going to go in the order that the problem gives it to us. So they give us our first volume. Volume 1 is 5 liters. At 1 atmosphere of pressure, so pressure 1, the first pressure we got to, 1 atmosphere. What is the volume? So they want us to find the second volume, so we don't know what that is. If the pressure is increased to 3 atmospheres, so pressure 2 is 3 atmospheres. Okay, and here's the model I was talking about. What you want to do is you're going to start with the portion or the variable that you're looking for. So we're looking for volume, so let's start with our volume number. We had 5 liters. And now I said multiply it by a factor. So we're just going to multiply it by a fraction and watch what happens. But the fraction has to give us the results we want. We want our volume to go down. We have 2 numbers to do that with. So the question is, what number is going to go on top of our fraction? What number is going to go on the bottom? Well, if we want our volume to decrease, we're going to put the smaller number on top and the larger number on the bottom. So a couple cool things happen when you do this. The first cool thing is notice we have atmospheres on top of atmospheres. So what's that going to do? Oh, they're going to cancel out. So what are our units going to be? In liters. So then we do our calculation, keeping in mind significant figures, so we're going to end up with 1.7 liters of helium when we're all said and done. Now, does that make sense? So did our volume go down? Well, we started with 5, we ended with 1.7, so yes, our volume did go down. Okay, now let's take out our pressure-volume relationships worksheets. If you don't have it, it's online. So take a moment and pause the recording for that. And we're going to look at number 1. So I'm just going to walk you through it. I'm just going to read it off the worksheet instead of writing it all out. It says a sample of 100 milliliters of oxygen has a pressure of 10.50 kilopascals. The pressure is then changed to 9.91 kilopascals. Assume that the temperature remains constant. So then they want us to predict, and then they want the new volume of the gas. So first of all, what are we dealing with? Again, we're dealing with pressure and volume. So let's look at what happened. We start with 100 milliliters, that's our volume. And then we have 10.5 kilopascals for our pressure, and then the pressure is changed to 9.91. So question, did the pressure increase or decrease? Alright, so our pressure decreased. We went from 10.5 to 9.91, so our pressure went down. If our pressure went down, what's going to happen to our volume? Right, so if pressure decreased, our volume is going to increase. So that took care of part A, our prediction. Prediction is that the volume will increase. So now we have to calculate the new volume. Just go in order of the problem. Volume 1 was 100 milliliters. At pressure 1, 10.50 kilopascals. The pressure is then changed to 9.91, so our pressure 2, 9.91 kilopascals. And the question asks, what is the new volume? So volume 2 is what we're looking for. Okay, now we have to set up the model. Start with the variable that you're looking for. So we're going to start with our 100 milliliters. Multiply it by a factor or a fraction that's going to make our volume increase. So we want our volume to get bigger. So if we want it to get bigger, which number is going to go on top? The bigger number or the smaller number? Let's go with the bigger number on top. And there are 9.91 kilopascals on the bottom. Kilopascals are going to cancel, so you don't have to do any crazy conversions with the pressures. Alright, so when we do that, our answer is going to be, with correct significant figures, we're going to get 106 milliliters. So, check it with our model, check it with our prediction. We predicted the volume went up, and did it? Yes. Another successful gas law problem solved. Please finish the rest of the worksheet on your own. Until next time.